Hi there. This is a demonstration video for our team Capstone project called the Bike Kollective. The project is centered around the development of a mobile app supporting a peer-to-peer bicycle sharing system. The motivation for this app is to provide a way to coordinate access to unused bicycles for free within a community. On the platform, users can both borrow bicycles to use temporarily and list their own bicycle to be used by others. In order to promote the use of quality bicycles, users can rate the bikes they just rented, allowing for a score to be aggregated and shown to future borrowers. The main technologies used for this application are React Native for the front end, Flask for the back end, and hosting on Google Cloud's App Engine. For the database, we use Google's Cloud SQL. Okay, before we go into the demo, here are our individual contributions to the project. I'll start with myself, Cameron Vigliano. I was responsible for building most of the elements of the front end. This includes features such as the user interface, the state management of that user interface, API calls to the backend, and device-specific functionality like location services and use of the phone's camera and photo library. The user interface started as a template made up of 6 screens using Figma Make, and then that allowed me to turn that into 12 screens and all have the same consistency and branding and styling from those original 6 screens. React Native is what's used for the front end. It's my first time using it, and of course it utilizes TypeScript. So it was pretty interesting experience. Allowed me to streamline the whole UI process by having both the components, so think like the structure of the pages, and the styling. So the equivalent of the styling and on like the web end would be CSS. So that equivalent was all used within a single TSX file in React Native. For state management and API calls, I was able to configure state variables to work with API call functions. So data from the backend can be rendered to the appropriate UI component. Some state variables required additional manipulation after being called or received from the backend before being set and rendered on to the front end components. I have some examples listed here, but we'll go through those a little later in the demo. Um, uh, TypeScript enforces type accuracy. So we did utilize whenever we sent something to the back end or pulled something from the back end, we were utilizing interface classes that TypeScript has to make sure that all the types were exactly correct on both sides. Um, for device-specific functions, the use of a mobile phone's location services, camera and photo library are used throughout the app, and you'll see that a little later. And yeah, I think that the demo is best served for that. And then moving on.
Thank you, Cameron. So this is Benjamin Primer. I was mostly responsible for building out the back end of the application. So that included building out the database, the API, and setting up some of the cloud infrastructure. So on the left here, you can see our database model, which shows the relationship between all of our tables. And the main objects here are bicycles, trips, ratings, users, and bicycle features. For the API, we use Flask, as Cameron mentioned, to for the to host the or as the server to send responses back to the front end, and that allowed CRUD operations on all of the tables I just mentioned, which you can see on the left. Another thing we implemented was a nearby bicycles feature, which was very important for the front end because it allowed a user to, or it allowed the application to find the user's location and then just return bikes that were close to them. And so this uses the haversine formula to find the distance between the user and the bikes, which takes into account the curvature of the earth. And then I also helped set up some of the protection on the endpoints so that users only properly authenticated requests were served. For the cloud, we use Postgres Cloud SQL to store our database or as our database. And then we also used Google Data Store to store the bicycle images. And then to deploy the actual API, we use Google App Engine as a platform as a service. And then I did step in a little bit on the front end too, and I helped develop some of the trip page, which allows users to see all their trips and high level stats about them. And then also the personal info page, which allows a user to view and change their info.
All right, hi, this is Kellen Grogan. My primary contribution was user account creation, authentication, um, requiring interactions on both the front and the back end. On the front end, I created the user sign up page, which collected basic data from the users, most importantly, email address and a password, which also handled error handling in case there were bad passwords, duplicate accounts, to prevent about 1,000 character HTML error, and instead getting your standard what you'd expect from an app. Also on the front end, this handled the front end storage of the JSON web tokens for sessions for transmission back to the back end for user account authentication. On the back end, again, handled the generation of a JWT user account login and a creation for session management. And then also implemented bicrypt hashing for user account passwords and validation. Importantly, there we didn't store the user passwords, just the hashes. So if there was any sort of compromise of the system, the only thing that would be available would be the hash. And then also with the account creation, handled the SQL Postgres queries that stored the accounts to make sure that the backend query to make sure that there was a unique user account. It only queried against passwords in case there were people with multiple of the same names, and then also use the same scheme to make sure the password complexity was fair from the backend. One of the challenges I ran into, which is worth mentioning, is I was supposed to also implement Google Auth, and because of the confluence with React and Expo, which is the deployment that we used, I just was not able to get that done in time. So the workaround ended up being the user account creation with the JWTs and authentication. And that is the end of my contributions.
Okay, now the demo. So we'll just bring you through a typical user experience. The app is loaded on your phone using a Android 7. You'll be met with, for first-time users, you'll be met with a intro screen. Okay, get started. You will be asked to enter your username or password, but since we don't have an account, we will sign up and create one. We'll create the account. You might see the logs down below. Actually, you should see what the password is in plain text. That, of course, is sent over encrypted into the database. Go to login. All right, send us back to the login. So now we log in with what we just created. And we log in. We are assigned a token that's later used to make sure that when you call the API, the correct user is calling that information. All right, these are the permissions for location services. So we will click yes while using the app. Sorry about that. I didn't have my locations set. This is a new device. So let's go through renting a bike, going through a single trip. As you see, we are in downtown DC. We'll zoom in a bit. We'll pretend we'll rent this bike. It shows our location from us, our nearest location. This bike currently doesn't have any ratings, but we will make sure it does. So on the bike rental screen, we're just presented with a number of attributes that describe it. The lot code, its bike type. So let's say we want to rent this. We'll click rent now. We get a number of reminders and also basically some information that we got from the previous screen. We'll start the trip. And then that starts a timer, and then you're ready to go. Let's just say we took the bike just for a short ride up the street, maybe to this corner here. I'll create that in my emulator. I'll set the point, and that will update in my on my device. We will end the trip, and we are then presented automatically with a rating screen. Let's say it went really well, it was really quick, nice and easy. We will click submit, get OK, and then we are then left with the map, and we are shown the bike in our location that we descended, and the bike that we just rented. You see it right here. And you can also see it in your previous trips right here. This account also previously rented a Trek bike.
Hey, this is Kellen jumping back in there. As you can say, we're in a mature but still build phase of this app. The team found it very beneficial as an exercise in bottom-up app development, and especially the remote teamwork aspect. Um, we think this is a good prototype app for people to build for other use cases. However, from a business development perspective, we identified many flaws to make this system work, um, mostly from the crowdsourcing aspect of it. So if we were to continue building on this, we'd really have to change what the uh, out goal of the project is. From a crowdsourcing perspective, we don't think that there's any use for continued development of this project. But we enjoyed it, and we hope you will enjoy testing it out.